another review of exponential functions and logarithmic functions, and these are inverses of each other as well. So starting with number 17, you're solving for x. If you have no subscript with log, you have a base of 10. So the translation to this equation in terms of an exponential is power of 10. When you evaluate a log, that's an exponent. 10 to the negative 1, or 10 to the negative first power equals whatever you have here. So here we have 10 to the negative 1 equals the square root of x. 10 to the negative first power is 1/10 equals the square root of x. So we square both sides. 1 over 100, square the top, square the bottom, is equal to x. So there's our value for x for 17. For 19, we have the natural log of 1 over x equals negative 2. Well, this translates to base e to the negative second equals 1 over x. I want to solve for x, so I'm going to take the reciprocal of both sides. So I have 1 over e squared, which is 1 over x. This is equivalent to this, so x is e squared. On 31, I have the exponential equation. I can do a little bit of algebra and factor out e to the negative x. That's common to both terms. So I have e to the negative x times x plus 2 equals 0. So by the zero product property, I'm going to set each one of these factors equal to 0 and solve. But here, I can't, because this is an exponential function, and an exponential function can never be 0, because this graph will never touch or cross the horizontal axis. The other factor is x plus 2 equals 0, and I can solve for x and get x equals negative 2. So I only have one answer to that equation. And finally, on number 33, they give you a hint to do what is called a u substitution, which you're going to be doing a lot of that in the future. I'm going to let u equal e to the negative x instead of e to the x like the directions said. If that's the case, then u squared is equal to e to the negative 2x. That's e to the negative x times e to the negative x. And when I multiply, I add the exponents together. So now this becomes a quadratic equation in terms of u. So I have u squared minus 3u. The negative 2 is on the right-hand side. I'm going to bring it over to the left-hand side by adding. And now this quadratic factors into u minus 2 and u minus 1. So yes, my roots in terms of u are u equals 2 and u equals 1. But if I want to go back to the x-coordinate values, this is when I use my substitution. So one value, so since u is 1, u is e to the negative x. And so e to the negative x equals 0, e to the negative x equals 1 gives us a result of x equals 0. The other scenario is if I let u equal e to the negative x, I have e to the negative x equals 2. And when I solve for x, I will get minus the natural log of 2. So there are my two answers in terms of x for this equation.